We're waiting.
Okay, we're ready.
Hi, all. Thanks for joining us. My name is Bob Monahan. I'm with the academic advising team for ECEE students. And today is the pathway presentation on both the electromagnetics area and the circuits area. And we're going to start it off with Professor Constantine Balanis. And he's going to take it away with the EMAG area. So thanks for being here, Professor Balanis.
My pleasure. Ready to go?
Yes.
Yep, ready to go.
Thank you very much. Yes, electromagnetics area. You see here my name. If you missed my photo, here I am. This is on number 7 at Pebble Beach, just to make you somewhat jealous. Okay, I think it was 2013 when I played there. Okay. Electromagnetics. Oops, what happened here? There. Okay, let me. Okay, what's electromagnetics? Study of the charges, either at rest, we refer that as statics, and we cover that primarily in EEE 241, that everybody has to take it. And then we have charges in motion, they call that time varying, dynamics, whatever. We covered that in 341. Electromagnetics, they're basically described by 4 basic equations. We refer to them Maxwell's equation because he came up with them. Special cases, circuit theory, Kirchhoff's laws, geometrical optics, some of you may have taken, will take later, physical optics, and so forth. Maxwell, 1800s, born in 1831, passed away in 1879. Did not live very long. This is his statue in Scotland, and one of our graduate students from ASU. He happened to visit, and this is Scotland. He went to visit where Maxwell used to live. This is his house in Scotland. This is the graduate student, Subramanian Ramalinkan. And you can see here, there's a plate with Maxwell's equations, for the Maxwell's equation in differential form. So he sent me the pictures, and I'm showing to you. Those are Maxwell's equations in integral form. This is the first one, and which is basically in circuits, it's loop equations, where the last term in circuit theory, we usually leave it out because it's very small compared to the other ones. So circuit theory, as we indicated, it's an approximation to Maxwell's equations. And then the next one is node equations. Again, the last term is usually small in low frequencies. We usually leave it out when we do study circuit theory. While we study electromagnetics, is the basis of electrical engineering, no matter what anybody else tells you. Fundamental, challenging problems in wireless communication, packaging, stealth technology. Using Maxwell's equation, we can solve complex practical problems using what we call full wave solutions. When the Maxwell's equation that I show you, when we use all terms, that's what we call a full wave solution. We do not leave anything out. We treat the problem as a distributed devices or circuits, and not lumped. We don't use lumped elements like we do in circuit theory. Modeling devices using, I hear something in the background. Modeling. Okay. Here are some other devices. In this case, antennas that over the years, starting when the the cell phones, the antenna was exterior to the devices, and then they moved it inside so that it wouldn't break, it would look better, whatever. Again, what I studied electromagnetics, analyze, model, design antennas, RF microwave circuits, fiber optics, electronic packaging, electromagnetic interference, electromagnetic compatibility. Here's, for example, a base station with antennas in there. We use it for cell phone communication. For example, this is a microwave circuit. Here's a laptop, for example. Here's a cell phone. All those things, if we analyze and design based on using the electromagnetic theory. And of course, stealth technology, trying to make the aircraft less visible to the radar, ideally invisible. To be successful in electromagnetic courses, requires a solid foundation of mathematics, very intense in mathematics, physics, circuits, because we as engineers, we electrical engineers are engineers, not technicians, for example, okay? So we use a lot of math. Courses, prerequisite for everybody in electrical engineering. Everybody has to take EEE 241. As I already talked about, the static, but primarily cover statics. Then circuits, 202, and physics, 131, and the lab associated with it, which is physics 132. So the 241 usually taught fall, spring, maybe sometimes things have changed, maybe even summertime if there's a demand and there's availability. Again, mostly we're talking about static electromagnetic fields, but towards the end, we introduced time-varying fields, Maxwell's equations, boundary value problems, dielectric magnetic materials. Again, Maxwell's equation, and because they're differential equations, we have to have boundary conditions to solve for the unknowns. To take 241, again, we mentioned you need to take circuits, 202, physics, 131, and the lab associated with it, 132. Again, another course that those that will primarily specialize in take electives in electromagnetics, so that we'll talk about in a few minutes. You must take the second semester, which is EEE 341, which is primarily taught spring, fall, spring, and maybe sometimes maybe even summertime. If again, primarily time-varying fields, homogeneous and stratified media, transmission lines, waveguides, resonators, cavities, in other words, radiation, like antennas. We covered their lecture, and there's a lab associated required for EM majors. That's right. And EEE 241 is prerequisite. Again, repeating, take elective courses in electromagnetics like antennas, microwaves, optics, electromagnetic courses, advanced electromagnetic courses, EEE 341, 541, graduate level, and so forth. You must take 241. Senior electives, as I indicated, we have a senior elective course on antennas, EEE 443 is taught sometimes on a yearly basis. Microwave course, also the same, taught again, maybe on a yearly basis, maybe sometimes every semester, depends on the enrollment. Fiber optic course for 48, those are senior elective courses in electromagnetics, and all three require EEE 341. Graduate courses, we have a plethora, as to use what a big word that Howard Cosell used to use on Monday Night Football. Plethora, that means many. 540, 541, advanced course in electromagnetic theory. We have a graduate level course on antennas, 543, on radar, 544, microwave circuit design, 545, and so forth. We also have some 600 level courses, 641. Now, they are not taught very often, but they are taught, have been taught in the past. 641, 643, 647. Couple of courses on advanced electromagnetic theory, also on microwave circuits design. Graduate school, degrees, masters, somewhat specialized, more applications oriented. Often the most marketable degree for pursuing a career in government industry. PhD, you specialize in a given area. You do research and development required a degree which is usually almost essential for a position, a professorship at a university. Maybe even some companies, government agencies require PhD as well. Career opportunities, again, in academia, already said it, need a PhD. You do teaching, research, consulting. Of course, you need to write proposals, publish papers, review papers, supervise graduate students, and so forth. Industry, government, again, as I indicated, bachelor's, master's, even PhD. Some agencies, companies require maybe even PhD. Job opportunities, again, industry, some companies. We have many here locally in the Phoenix metro area, even from the time I came here, which is back in 1983. General Dynamics, for example, Lockheed Martin, Motorola was big one time here. Intel, Raytheon, and so forth. Government agencies, NASA, I worked for them back in 1964 to 70 for 6 years. The Army, the Navy, the Air Force, JPL, National Security Agency, NSA, Sandia, Aerospace Corporation, just to mention a few. Faculty in electromagnetics, Dr. Eberle, some of you may have already taken courses from him. Excuse me. This is me. Retired in 2021 after 37.5 years at ASU. Professor Imani, some of you have taken and will take courses from him. Dr. Pillay, probably the most senior faculty members in electrical engineering. He's also Professor Emeritus. He was here when I came here in 1983. Professor Pan, he is also now Professor Emeritus. And last but not least, Professor Trikopoulos. Again, you may have taken courses already. You will take courses from him. Faculty at ASU have published some books, used as textbooks. One is a book. This is the 3rd edition on antenna theory. I guess I happen to be the author. This is the 4th edition, which is in color. This is the advanced EM book, not undergraduate, graduate level. Used as a textbook in EEE 541, 641, maybe even 643. This is just a small book, Introduction to Small Antennas. Again, I co-authored that book with one of our former graduate students. handbook on antennas that I was the editor, a book on fiber optics authored by Professor Pillay, and a book on the wavelets in electromagnetics, authored by Professor Pan. And this is the third edition of the Advanced EM book, which came out in January. The publisher insisted that they put even my name on the title of the book, as you can see there. We have one of the most advanced antenna facility. We call it anechoic chamber in a university, probably the second largest, and also instrumentation-wise facility in academia, other than the one at Ohio State, which dates back in 1940s, 1950s. We built this one in middle 1980s when I first joined the faculty at ASU. EMAC, electromagnetic anechoic chamber. We do antenna measurements, radar cross-section, and so forth. Is, as I say, it's a good facility as you can find in a university environment. You can see their scale model of a generic helicopter. Let me just, before I conclude here, give you my personal viewpoint as to why electrical engineering, why electromagnetics. I worked for NASA for 6 years. I taught at West Virginia University for 13 years. I was at ASU for 37 and a half. I even put the half there to be exact or more accurate. And why golf? Now, if you want to know the answers to the above questions, you can go to YouTube and you can put down Legends of Electromagnetics, Professor Constantine Balanis, and you will see there why answers to the above, why I chose electrical engineering, electromagnetics, why I worked for NASA, and so forth. And within the last year or so, they even gave me a medal, which says Legends of Electromagnetics. Okay, that's a kind of personal promotion, huh? Now, I thank you for your attention, and I will be more than happy to try to answer. I did say to try to answer the questions.
No, I did.
I'm open to questions. Thank
So
you very
just-
much.
Yeah, just so you know, I put the video of your legendary interview in the chat so people can watch the video directly. And there are a couple of questions here, but I want to know what sort of, did they make your metal out of plastic or wood? I was curious.
They make the metal out of what? I'm sorry.
Did they make the metal out of plastic or wood?
Oh, no. It's a metal that, in fact, I have it over here. I don't know. You can see it. No, this is, I think the metal cost IEEE, my understanding, like $1,700. It's a
Ooh.
3 inches in diameter. I have it right here. I'm admiring.
It's gorgeous. I did see it and I held it, and it's a hefty metal. Now I should get
it's
to the
heavy.
student.
The thickness, it's maybe like maybe a quarter of an inch. I think the thickness, it's copper, I think, whatever. No, it's metal.
So you guys are hearing from a real legend today. He's actually a
yes,
certified legend. So
please
we do have
refer
one.
to me as the legend, please.
We do have one question in here. So if
Yes, sir.
so from David Rock, he's asking, what do you think is the most important question or problem that EM can be used to solve? That's a broad question, but what are your thoughts on that?
What is the most broad problem
what
that
do you-
EM can be used?
Yeah, what's the most important question or problem that EM can be used to solve?
All important problems, as I said, circuits, antennas. Remember to, if you want to make a structure stealth, like a high performance aircraft, in micro circuit design, optics, all those are very important. I don't have one in particular that EM can be used. They're all challenging problems. If you need to treat them as a full, using full wave solutions. In other words, not to leave any terms, based on Maxwell's equations, any of the terms out. So I don't have any one particular, but I worked on some of those problems, including stealth technology. I have published with my students, of course, even when I was at NASA Langley Research Center back in the 60s. So I think all the problems that we addressed, we researched them. We're not doing it just for fun, for playing around. I think they were important problems.
Yeah, there's another question on stealth to elaborate on what is stealth technology used for. I think you had an example of a military plane, but what is your answer to that? What is stealth technology used for?
Yeah, to try to make a target less visible to the radar, not to be able to, to try to avoid detection by the radar. Now, you cannot make it if it's a flying platform like an airplane. You have to compromise. You cannot, even though we can make it ideally very, very less visible to the radar, but if it's a flying platform, it has also be able to fly. So we have to compromise between flying performance and electromagnetic visibility to the radar. In other words, to avoid detection.
Okay, yeah, thanks. And then there's another question about job. There's two questions about employment. One is, and I know the answer to this, but maybe you can answer. Are there non-government contracted jobs that EEs can get? And I think the answer is yes. You've worked with a lot of you worked with government agencies and private world, correct?
I didn't involve for a private company. I did consulting for companies like Motorola here locally when I came. I had contracts with many companies. I put together what we call a consortium, which was a group of government agencies and industrial companies here at ASU. We started mid-1980s. We call it AHE, Advanced Helicopter Electromagnetics. We had like 55 members, which lasted 28 years. So we had companies like Motorola, like Rockwell International, companies like NASA, the Navy from Maryland. Most of them, other than locally here, it was McDonnell Douglas initially. Okay, the helicopter company here in Mesa used to be McDonnell Douglas. Okay, initially, and now it's Boeing. They were members of the consortium, which started mid-1980s, lasted 2018, 2019, 28 years.
Yeah, and I would say that the electrical engineering major is broadly, among engineering, it's one of the most, our students do not struggle finding jobs if they do, reasonably well in their courses, and internships are very critical, particularly if you want to work in the private sector. But yeah,
if you look at the IEEE, Institute of Electronic Engineers, that it used to be IRA back in 1963, which is the name. Then the two societies before IRE and ASCE, they joined together and they formed IEEE. Okay, within IEEE, there are 39 specialties. There are 39 different journals, publications. You talk about electromagnetics, microwaves, solid state, power, electric power, okay, signal processing, digital DSP. So they 39 different specialties, the most diversified specialty in engineering, electrical. I know we electrical engineers, we expect me to say that, but it's true. You can find, as Bob already said, that you can find a job just about anywhere, everywhere and anywhere. If I
Yeah,
can
and
say.
there's a couple other questions I want to rush to get most of them because there's a great questions today. So thanks
Sure.
for putting them in there. There's so there's a question about difficulty. There's a student interested in communications. Everyone tells him that EM is the most difficult course in EE. What do you think is necessary to be a good student in EE and EMAG courses at ASU?
Listen, back in my days as an undergraduate, there were a course in electromagnetics. There was a course in circuits. Okay, and of course math required for EE majors. So you have to have a good background in mathematics to succeed in electrical engineering. Okay, people in communications, okay, should take courses related to electromagnetics. Of course, everybody has to take the 241, but I highly recommend that they even take 341, because again, 241 is primarily statics. 341 is where we talk about time varying fields. For what's so it's very important that people that work there, they're going to work eventually in wireless communication. EM and wireless communication, they go together. So highly recommend. And also I recommend that people in electromagnetics take courses in communication, digital signal processing, and so forth. You understand? Both ways. It's a two-way street.
Great, thanks very much. There's a couple of others in here if you have a minute.
I have plenty of time.
Oh, great, thank you. So would Nick is asking, would EM be used more for design, or would this be more useful for test and evaluation skills?
Design first, I think. Yes. If you're going to design something, we talk about, design low visibility target to the radar. You have to use EM. Okay, an advanced circuit, the design that requires where you treat the circuit as a full wave. You need to use full wave solver. You use it. You treat it as a distributive circuit, not a lump circuit. Just like it is. Okay, no approximation. We're gonna let's say approximate part of the circuit with a lumped element, like a resistor or a capacitor. You treat it just like it is. We call that distributive circuit. So we use to solve it, to design it, using Maxwell's equations in full form. We have software there. There are software available, commercial. One in particular, HFSS, High Frequency System Simulator, that you can use to solve complex problems. Okay, the technology has advanced. Nowadays, there are software, commercial, where you can use to solve complex problems. EN, treat it as distributed circuits. But before you just dive in and just use the solvers, the computer programs, I highly recommend that you take courses, you understand what you're using. Okay, we never expect you that you're gonna write a new software. You can use the software provided you have a good background on the basis which that software was developed. What are some of the shortcomings? What are some of the strengths, some of the shortcomings of a given software? everything has limitation. Okay, it's not 100%, might be 98%, but not maybe 100%. So good background. Yes, you don't have to write your own software. They are available. But take courses, you understand what you're using. All right,
Great.
another question?
Yeah, it looks like there's two are career related. So I wanted to tell students that first, if you're wanting to do more than your degree to make yourself marketable after graduation, definitely seek an internship. And I put a link to the Engineering Career Center into the chat, so please use that. There is an upcoming career fair that online and Tempe students are able to attend. There's a follow-up question from David Rock. He's 57 years old. When he's finished with his electrical engineering studies, and he's working currently as a full-time IT person, and he wants to know tips on employment. Internship will probably be difficult for someone working full-time. My quick answer to that would be to attend the career fair anyway. I would go there and network with people in the field. You might ask them what they're looking for. I would also say engage in discussions with your faculty during their office hours if you have questions on your courses. We do have online students occasionally doing research with faculty too after they've established relationships like that. So if an internship doesn't fit in with your professional schedule, well, I would try to make it happen. I know it's a lot going on, but you could also engage directly with stuff happening on campus, even if you're an online student, by talking to your faculty face-to-face through Zoom meetings, asking about research opportunities. Do you have any comments on that, Professor Balanis?
Yes, 57 years old. He's just getting started. He's just fresh, compared, I worked till I was 82. Okay. So he's got plenty of room. I think we are very fortunate. And one of the reasons why I came to ASU here in the Valley, in the Phoenix metro area, we have a lot of companies, aerospace companies, opportunities to work part-time, full-time. Yes, internships you mentioned. I already listed some of the companies here. I don't have the companies, as I indicated. Motorola used to be big over here. Intel, again here, Boeing in the East Valley, Honeywell in the northwest part of the valley. Many companies here locally. I'm sure there are opportunities for part-time, full-time. So I encourage him to, through, as you say, ASU offices, look for opportunities.
Well, great. I think, we have one last question about laboratory works that happen in the online 341 versus the in-person 341. I'll let you answer. I know that Professor Aberle usually teaches those in recent years. I know a lot of the kind of the exercises that are done are used in software like MATLAB. Do you have any other knowledge on the laboratory work done in 341, Professor Balanis?
Unfortunately, I do not, because I did not teach 341 much at ASU. So I'll let Dr. Aberle, Imani, Tricopoulos, answer those questions. Not to mislead anybody in exactly how they do now. Back in the early years at ASU, when I was there, everybody was on campus, undergraduate. So they used to take labs in person. Nowadays, of course, a lot of things are remote. So I better leave it to somebody that can give a good answer on that.
Yeah, I put the syllabus for that course for the online version in the chat. And I also know Professor Aberle, who teaches the online version, he's pretty quick to respond to questions. So feel free to ask him if you're curious. I do know they do a lot of software simulation type stuff, and the goal is directly to get you experience with MATLAB at a higher level than you have before. That course is really useful for that, because that's a skill that employers are looking for. And that's the last comment I want to say to David is, if you take courses that have those skills built in them, specifically, look through the syllabi and all that, but if they're if the course gives you access to a software that you can only get while a student, that's an employable skill right there. So just students know when you get into the upper division of the curriculum, one of the benefits of being a student here is you're taking courses and you're using industry specific software. And these
Yes.
software licenses these are like $1 million licenses. So you would never get to touch them unless you were a student in an engineering program. So I would definitely recommend that. And we are a little over. I need to jump into the circuits part now. I think that was most of them. So I talked too much, Dr. Blunt. So we appreciate having the legend with us today. I'm gonna move over to the circuits area in just a moment. Any parting words for the team, Dr. Balanis?
Yes, I just want to say that, thank you for the invitation. Appreciate it. I've been doing this for quite a few years. I know I've been labeled as talking too much, but I think you do a pretty good job. So the label needs to be placed upon another person instead of me.
Well, that's what I said. I said I talk too much. I was blaming myself this time. I was being nicer than usual. I'm usually quite hard on you, and I was trying to be nice to you today, and it failed. So
yes, thank you. If anybody has questions, you can always send me an email. I'll try to address it if I can. Usually I'm not on campus very often, but I do have the office there. I come on campus occasionally. So anybody has a question, you can send me an email.
Well, thanks again for being here, Dr. Balanis.
My pleasure.
Students, we joke with him a lot, but he really is a legend in the field, no joke. And
yes, very valuable.
If you take courses with us, you'll see his name. If you work in the industry, people all know him. So when you get your first time jobs, ask your employers if they took an EMAG course, and chances are they've read his book, and that's kind of a fun connection to make. So thanks again, Dr. Balanis.
Okay.
Yeah, he needs royalties when he does this. He doesn't do anything for free.
Okay.
All right, thanks all.
Thank you so much for helping us out today. We appreciate it.
Have a great day. Thank you.
Thank you.
So hi, students. We had a little bit of a glitch, and our circuits faculty has not joined us, but I'm going to put the presentation up and go through it. So apologies for that. So give me a minute to put this up there. And Cheryl, are you seeing my circuits presentation?
Yes, I am. It's
I can see it
in presentation mode, but I could see it.
Okay, there we go. So thanks, students, for bearing with me. Well, I'm going to go ahead and roll through some of this, and any advisors or anybody who wants to comment, please do it. Unfortunately, Professor Kitchen's not available to join at the moment, but I think I can add some context to this and answer plenty of your questions if you have them about that. So circuits areas is the biggest of the academic areas in EE. Circuits area is very, it's grown a lot in recent years, and there's been massive investments in circuits in general and internationally. ASU is involved in a lot of the growth. Phoenix has multiple fabrication plants being built. So circuit designers are in high demand. Now, that doesn't mean any of the other pathways don't mean you can't work in the circuits industry, so remember that. But if you're curious about circuits, this is a great place to be. So mainly the areas that we teach at ASU, when you get to the upper division of the curriculum, you learn about analog circuit design, AIC, digital and VLSI circuits, microelectromechanical systems, the MEMS area, and we have faculty doing all of these specialties, emerging devices and circuits, and then RF and microwave systems. So these are kind of our 5 of our major areas that EE faculty are doing research in, and we teach courses in. These are the faculty that you'll get to know in their courses. Slightly out of date, but we have, so you can see the list there. Probably the most popular group that we see students taking at both master's and undergraduate level are, the top 2. I know our international students and graduate master's students they come here specifically and they really crowd into the circuit design courses like VLSI and digital circuits and analog circuits. And I know directly that those students are getting hired at very high rates. So that's kind of a quick way to get employed when you take courses within that area and do well in them. The circuits faculty are actually, if you're on the Tempe campus, for those Tempe campus folks, or on the online students too, we hope that you come to campus one day, and the circuits faculty are all located in the ISTB4 building. And it's a really cool building, so I encourage you all to check it out. If any of the Tempe students haven't visited yet, or online students, if you come to town, take a trip over to ISTB4. It's essentially like a big museum, and there's really cool stuff in there. It's also the home of the Earth and Space Exploration programs at ASU. And that's one of the reasons that the circuits faculty are over there, because they're involved with exploration systems, systems design and all of that stuff. And so those Earth and space folks need the circuits people to design their systems, the electronics and stuff. So make a trip over there if you have not already. It's a really cool building. There's a lot of it's open to the public, and there's just really cool stuff. And there's actually a meteorite. Anyway, there's all kinds of stuff in there. Check it out. Where circuits are applied, this is very general. You probably know a fair amount of this. And I specifically don't want the faculty to update this slide because I like how old the cell phone image is there, and the computer with the sideways football player is funny to me. So that laptop is quite old, but it's important in wireless communication, of course. And what the other thing about this, each of these areas, you can find companies doing it locally in Phoenix. So even if you're not a Phoenix resident, for the online students, you might find your way here in the future because we're kind of a hot spot for this kind of technology. So power management, wireless technologies, biotechnologies, I think that's an image of some kind of hearing device, but that's a big deal. Aerospace, automotive, security is big and growing field. So these are all over the place. This is a little bit more about our courses that we teach. So the undergraduate courses are in the white boxes at the top. And the graduate courses are in the lower boxes. So if you're curious about a master's degree, or if you're curious in the accelerated master's program, the AMP program, we're calling it now, to amp your career, which I love. Lynn came up with that little slogan, one of our grad advisors. But you can take more courses at the graduate level and become even more employable. So the pathway to do it is, if you're curious about the analog stuff, you'll stay on the left of the screen here. If you're curious about the digital stuff, you'll stay on the right. In the middle, there's 3 options in there too that kind of bridge the gap. So learn more about that with your advisor and as you take the courses. So my strong advice is those of you taking 334 and 335, if you want to take more circuits stuff, is set aside a time to maybe chat with your faculty outside of class. Maybe ask for office hours if you're curious about working in one of those fields. Those appointments or those discussions will give you a lot of benefit. And I strongly recommend make that separate from any class discussions. Just say, hey, I'm curious in working in this area in the future. What do you think is the best next course? It's the best next course of action. Do you recommend a master's? Do you have any professional contacts? That sort of stuff. Your faculty are part of their contract is to serve you in that way too. So do well in the course and then ask some professional questions as you get to it. Some specifics I'll let the faculty cover, so I don't want to get too much into things that I don't want to cover too much detail on some of this stuff. The point is that research is happening at ASU by ASU faculty member, and we're kind of a big we're a big growing expert in these high level circuits areas. At the bottom of this slide has some general employers that hire circuits people with this background. So the big ones like you've heard: Qualcomm, Intel, Microchip, Freescale, Texas Instruments. Many of these people are local, so keep that in mind. I'm gonna kind of go over that one. This is example of some research that a former professor of ours used to be involved in. Gonna skip in that too. Yeah, this is a fun one. So this is an example of Dr. Jennifer Blaine Christian's work. She's interested in kind of medical applications of electronic circuits. And I like to point that out. So if any of you have friends in school or colleagues in school who are curious about biomedical applications, know that you can get towards that with an EE background. So it's, biomedical engineering is a great field of study, but it's not the only way to get into biomedical work. Obviously, electrical engineering students will have more background in electronics and circuits. And so the BME folks often need to work directly with people with EE knowledge to do it. So the reason I'm stopping on this one is don't limit yourself to, not that there's anything wrong with going and working in circuit design in a large company like Intel. That's a great career path. But know that if you're curious about, improving quality of life through electronics and circuits, you can do that. So locally, we have companies doing that work directly, and there's research being done. I have a couple of friends working at oh, someone help me out here. The local biomedical technology company. Oh, it's right here in town. I'm completely spacing because I wasn't prepared to talk today. Oh, someone knows it. Someone put it in the chat. You know what I'm talking about. It's huge. Dr. Balanis, which one am I missing? It's a biotech company locally.
I'm trying to think which one.
Medtronic. I was thinking Medtronic.
Oh,
Thank you.
Medtronics. They're
Yeah.
They're up in the northwest part of the valley, I thought.
Yeah, and there's an interesting, my friend who works over there, one of them is a metallurgist, so she's not an EE, but she works with electrical engineers on creating circuits and alloys that can be on the inside of a body and work properly, which is a really cool problem to solve if you think about it. So you can't just put anything that you put into a computer inside of the body because the conditions are different. So it's just an interesting, EE can be applied all over the place, particularly the circuits area. And we have circuits folks working in the sensors area, which is a large growing area. And I'm going to skip most of these other research things. So, and jump to the career stuff. This is quite out of date, but it still makes a good point. So just this has expanded quite significantly. And up in the corner, you see there's a new TSMC site in the valley. That is not a small thing. That's a major development. So that's over 50 billion with a B dollars investment TSMC made in the Phoenix area to develop a new fabrication plant. It's a big deal, and it's going to make big waves in who's producing the most complex chips in the world and where they're being done. Anyway, these are some of the other employers. I know Dr. Balanis already mentioned places like Boeing and aerospace companies. But these are folks that hire. These are out of date, but just kind of, I would put a multiplier on pretty much all of these. EEs do not struggle in finding work at these companies. Continue to do well in your courses and attend career fairs and all that, and you'll know they're there. This is kind of a continuation of this. So NVIDIA is large, and then Cadence Design System is one of the softwares that you'll get access to later if you take certain courses. That's one of the licenses I mentioned before. Just being an EE student will get you direct experience with Cadence software, which is how they design and map out circuit design stuff. And you don't get that unless you're a student or an employee. So that's a great benefit of being a student. Here's some of the other companies that students work for. Yeah, and the list keeps going on. There was a question earlier about government collaboration. I know we have some students who are military students probably on the Zoom with us for the online program. We have we're real proud that a lot of veterans and active duty students have found their way to our program. A special thing to keep in mind is a lot of the students with military backgrounds often come with clearances military level clearances, which give them a direct line to certain jobs. So if you have any sort of military clearance through your work or your service, I would attend a career fair. A quick anecdote on that is we had a student, they were a graduate student, but they have had a military clearance through a project they were working on. And pretty much they got pulled to the front of the line because that's who they were looking to hire. So don't be afraid to ask about that. So there are government labs and that might have clearances that you can work for. There's Medtronic. I was talking, should have waited. I would have seen it there. This one's quite outdated, especially now with Arizona growing. That percentage is way out. So let's skip that one. Compensation has gone up. These are medians, so these are not entry-level salaries. Salaries are quite high for undergraduates in the circuits area specifically. Again, this is outdated, so don't put too much weight on it. I will say if you're considering a master's degree, there is a significant jump up in pay and career options if you get that master's degree. So I think pretty much in any of our curricular areas, if you graduate with a bachelor's degree, you'll have great job opportunities. You'll have even more if you get a master's degree. And I would ask your advisor about 4+1 if that's an option for you. That's not to say you have to do it, but it's a great way to do it. Those are the basics. I do want to answer questions at my level that I can do. So I want to give some time for that. Let me skip around here. I've got too many windows open. And if someone
Bob, can I ask you, can I make a comment?
Oh, please do. You bail me out here.
Okay, well, if somebody's thinking about going to graduate school, and I highly recommend, okay, to try to do it as soon as possible, meaning instead of delaying it until when you get older, you know what I'm talking about, it's more difficult. You have an established family, you may have kids and so forth. So if you're thinking, if you have aspirations to go to graduate school, do it, okay, as soon as possible. Continue, get it over. Get it over you. As you say, compensation increases when you go from bachelor's to a master's to a PhD. It gives you also better opportunities, you know what I mean, advanced level. So I highly recommend, you know, again, I taught for 50.5 years, besides working for 6 years for NASA. So I have seen students all the time asking me questions. Should I go to graduate school? If you have aspirations of graduate school, do it. Do it now. You're fresh. You're still technologically, you're up to date now. Do it. Later on, you may be out of technology. You know, you will work somewhere for, let's say, 5 years, 10 years, whatever, and then decide to go to graduate school. You're competing with a different generation.
Yeah, thanks. I think we have a second from David who mentioned earlier he's not of traditional age, and he's seconding your comments wholeheartedly just because it does get difficult to do things later in life.
Well, yes.
You got to pay bills and you have families and all these sorts of things. So it's lots of people commenting on that. So, but special hats off. That's where we're real. We know a lot of the online students here today. You're doing it in a tougher road, and you know, stick with it. You know, you can do it. A couple other questions here are: do undergraduate? Well, first, is it possible for online students to visit the antenna facility? I would say if you're curious, and there's another one asking about maybe visiting the NanoFab facility or the clean room. We actually have those. It'd probably be best to take courses from faculty who are in those areas and ask them individually. We don't do organized tours of the facilities, but typically students, if you reach out to a faculty in the area, might be willing to show you around. You might take that one offline to your advisors, and maybe we can start a conversation if you specifically want to see a facility. Scheduling that can be complicated, but we're not opposed to looking into it. Over for Tempe students, Brooklyn is asking about fabrication facility, there is a clean room in the ERC building. And you can actually look in there and see students working in the bunny suits sometimes. It's in the back of ERC on the first level. It's a public building. Walk towards the south end and you can actually see in it. And the nanofab facility has some faculty associated with it. You might reach out to them when you take some upper division courses and see if they could show you around. What's the best path to circuit designs with Medtronic? Fahad's asking, I would say take the courses first and then engage with the faculty directly and then reach out to Medtronic directly to see if they have internship positions, I would say. If you're looking to target a specific company, seek an internship with them and get good grades. That's the best way to do it. I don't know that the faculty I mentioned works specifically with Medtronic, Jennifer Blaine Christian, but she is directly involved in biomedical stuff. So she could be a good person to do. But definitely take those courses and seek internships with Medtronic if you're curious about them. Let's see, a couple other in here for time. Physical, so for online students, if you want to use physical equipment for the labs, aside from the kits, I'm not sure how to answer that, so I would maybe ask the faculty directly. I'm sure there's probably a way to work that out, but I would say that's a great question to ask your circuits faculty in office hours to see what exercises you could do with equipment. I think a lot of the lab kits, you could probably get a breadboard and do some of the stuff on your own. But the labs that are done in the building in 273 aren't dramatically different than the ones using on kits, but I'll save that one for the faculty. So sorry, they're not here to answer that directly. And then a couple more, I'm going to try to squeeze these in. Oh, for circuits path, is there a significant difference on what students can get out of the program online and in person? I think it depends. It's probably similar to any other campus. I see Tempe students who don't engage at high levels, and I see online students who, knock the Tempe students out of the water on the engagement level. And by engagement, I mean working with faculty, making use of the software that you have access to. So for sure. Another comment on that, this is for Amanda, is if you are wanting to do more than just take your courses, online students have access to similar things that the Tempe students do that are extracurricular. You can be involved in a Fulton undergraduate research initiative. You can be involved in an EPICS project, which is kind of a project that connecting engineering and community service. If you want to do more than take your classes, that's a great thing to make an appointment with your advisor about and just ask. There's websites on that, but that's best discussed with an advisor just to engage at a higher level. So I think that the outcomes in the career world and the job applications that I've seen, I don't think there's a dramatic difference. And it just really depends on what you do in addition to supplement the degree. David Rodriguez is unsure about pursuing a master's degree. Any advice on that? I think we've talked a little bit about that. I would say it depends. And Dr. Balanis might have his own comments, but I'm going to say you don't need a master's degree to get fulfilling work. You will have more options if you have a master's degree, but don't get a master's degree if you don't like taking classes. That's my personal advice. So some people are just going to power through it even if they don't and love it. But I think it has to do, there's some level of personal interest and excitement that needs to be in on it. Do you have comments on that?
Yeah. Listen, if you're thinking about a student, thinking about maybe eventually going to teaching, you need a PhD. Okay, all universities, colleges, even universities required. Now, when I was back in the 60s, I had faculty, professors in my classes that I was taking did not have necessarily PhD. But nowadays, if you're thinking that one day you want to go into teaching, you must. Okay, and you said it correctly. I think, with every advanced degrees, more opportunities. Okay, it doesn't say that with bachelor's, you must have a master's. No, many opportunities for bachelor's degree. But the technology is advancing. So are the methods for solving the problems, which usually cannot be covered all in an undergraduate curriculum. You go to advanced degree, more specialized in what you wanted to do.
Yeah, well,
It's not
thanks. And
essential, but it's recommended.
yeah, and you can go, and many of the online students know this, many of them are already working in the field, and you
Sure.
can go quite far with limited education, but it's harder. It's a harder path, and there's less, you have to kind of form it. So it really depends on the situation. If you like the idea of taking classes and you want more doors open than closed, I definitely recommend it if you have the time and the resources.
It's
We are in,
self-satisfaction. In other words, what do you want one day to be? It's not just the money necessarily. You know what I'm talking about? Is what do you like to do? You want to get an advanced degree, or you want to pursue advanced technology or whatever. You want to specialize into something, and that's when you do it with the advanced degrees. You cannot do it, at a undergraduate degree, where you have a number of students in a class, for example.
yeah, if you want to be a legend, you should go to school for as long as Dr. Balanis did.
I knew you were going to throw that in.
Well, we are at time. Thanks for sincere thanks to Dr. Balanis sticking around and being the adult in the room, the faculty member in the room. I appreciate it. Gia just put in the link to the career fair. Thanks for doing that, Gia. And thanks, students, for being here. We're going to go ahead and wrap up, but this was great. Thanks for indulging while we covered some of the circuits areas. Sorry that faculty wasn't here. We'll take care of that next semester, so you can join us then. Thanks, Dr. Balanis, and thanks, students, for being here. We appreciate it.
Thank you to all. Thank you to all.
Take care.
Have a great day.
You too.